Hi and welcome everyone. Thanks so much for joining our webinar, Real-Time Fraud Detection Using AI. It is a hands-on guide with Akmal Chaudhri, who is a very regular speaker at our webinars. Thanks for joining us, Akmal. He's really joined us for this webinar at a very short notice. So we really appreciate it and really appreciate everyone for tuning in with us today because this was a topic that has been really popular and the team really wanted to repeat it. So thanks everyone for joining and we'll start real soon. Can you go to the next slide now, Akmal? Thank you so much. So if you like this topic, feel free to join us next time. Tomorrow we are presenting FreeDB Faceoff, MySQL versus Postgres versus SingleStore free tier. So it will be like, again, it will also be a hands-on guide and you'll actually see how these databases are handling like huge chunks of data. So, and we'll see milliseconds response time and like what's the difference in each of this database in like, real time. And it will be presented by Madhukar, who is our CMO and a senior technical evangelist here at SingleStore. And on October 14th, again back on popular demand, we are bringing back how to build an LLM chatbot powered by agents. This will be presented by Vinija. She is a she is the AI. I think she is an AI lead at Amazon currently, and stay tuned for it. And if any of these topics are interesting to you, feel free to RSVP right now. And I hope to see you all there. So moving on, during today's session, we highly encourage you to sign up and try SingleStore today. Anyone who tries out today's tutorial will be entered for a chance to win either branded new Meta's Ray-Ban sunglasses or branded new AirPods Pro. Simply click the link that's present on your screen, and I'll be putting everything in the chat as well. So stay tuned for that. And you can just sign up for the free trial. I'll be providing Akmal's notebook for you, like to load in your data and maybe use it as an inspiration for your code. And you can follow up in real time because, as I mentioned earlier, it's a hands-on guide. So feel free to tune in and follow closely with Akmal. I will also like to tell you that we will be taking up questions live during this session. So you can use the Q&A button, which is present at the bottom of your console to communicate any questions that you have. Just keep in mind that we don't take any anonymous questions. So feel free to put everything in and whatever doubts you have. And I think we can get started. So thanks for joining, Akmal, and the mic is now yours.
Great. Well, thank you very much, Yukti, and thank you all very much for joining. And so, as I always do, I check my my phone, and it's just gone 6 p.m. my time. So we are, I think, daylight savings is coming soon, end of October for us in the UK. So there will be a sort of period of time when I think it impacts the timing of these events, certainly as far as I'm concerned. But anyway, that's another story. Okay, so thank you very much. So there we go. And in terms of agenda, I'll talk a little bit about AI and ML with SingleStore, and because we are focusing very much on fraud detection, then from the financial world in banking, this is going to be an important topic. And I did a kind of an analysis of looking at some ways that we could utilize, existing techniques that we currently use for fraud detection versus machine learning techniques, which are sort of fairly widespread and available today. In terms of tools, you can pick a whole bunch of very useful technologies and packages and libraries to do that for you today. Versus, I think the AI, the conversational AI that we currently have with things like ChatGPT. But equally going forward, I noticed that many of these LLM providers are coming up with some very useful libraries. So OpenAI, for example, just announced something focusing very much on kind of computational, and then giving you much sort of deeper insights into the data. That, I think, is a really good direction to go in. But I'll show you and share my assessment of where I think things are today, and we'll go forward from there. And as Yukti mentioned, please take the opportunity to sign up. So she will have shared the link for this in the chat. Okay, so let's have a look. Let's take a look at that. So for the cloud trial, okay, And I mean, it's here, as you can see, but she'll post that in the chat for you. So this is a very useful way to get yourself a free account. And as soon as you log in, you'll be able to access the resources immediately. There was a time when you had to fire up some compute resources and so on. It's all taken care of for you. If you open a brand new account, literally, I mean, it's a minute of your time or so, just using Google or Microsoft or the traditional old-fashioned way of first name, last name, and email address, and then just click the continue button, and it will just walk you. I mean, there's a little bit of a wizard. You'll get asked a couple of questions, sign up, and then you get an email. You'll verify, and then that will get you into the portal, okay? Which we'll have a look at shortly, and I'll share the the resources with you. So the Yukti will post those into the chat as well. Okay, so two quick slides on the company and the product. So this one is always a nice one to show, especially if you're sort of have not heard of the company before. Maybe you are a little bit concerned about, who is this company called SingleStore and what do they do and where are they from? Well, we've been around for quite some time, actually. 2011, originally founded as MemSQL. So the product, the mem part should really give a clue as to what we used to do in-memory processing. And it was focused very much around online transaction processing, OLTP. So kind of, the banking type of applications. And subsequently added support for column store. Okay, so analytics, sum, min, max, average count at scale. And then obviously it didn't make sense to continue calling yourself MemSQL because the column store, this is persisted to this. So there was a rebrand of the name some years ago, okay, to hence the name SingleStore. And that seems very apt and very appropriate. We are a $100 million plus ARR, annual recurring revenue company, and over 350 global customers as well. Okay, and so if you look down at the bottom in terms of the investors, you can see some well-known names there. And actually, some of these investors were customers first. So it's the analogy I use, the story that I sometimes tell that it's like the gentleman who bought the shaver, and this is a real story, by the way. It used to be advertisements on television. So he bought a shaver from a company. He liked the shaver so much, he went and bought the company. So in this case, these investors were customers. Some of them liked the product so much, they decided to invest in us as well. And as far as the product is concerned, well, this is a kind of nice high-level overview. It just shows you a little bit about the some of the key features and integrations that we have. So recall that I mentioned on the previous slide that we moved away from just being OLTP to being OLAP as well. So subsequently added this kind of universal storage, the ability to handle both of these types of processing in a single table type, and lots of integrations. So if you are working with streaming data, for example, Kafka for that, transformations using Apache Spark, for example, or you're getting data from other sources such as S3 or Hadoop HDFS. And we have this very nice concept of pipelines. And I've actually just been revisiting some of the old content that I wrote some time ago and looking at updating both the text of the blogs as well as the code itself, making sure that that still works. And this concept of pipelines actually comes up very often in the previous content that I've written. It's a very useful technique to stream data in. And particularly for this type of application where fraud detection, you want to do things in real time, you want to be able to get that data in quickly and be able to process that quickly. Something like SingleStore Pipelines, I think, would be an ideal solution. One other technology, I should add, that I experimented a little bit in the recent past with Spark streaming as well. So I took a simple case of saying, well, let me generate some text messages. These could be representative, say, email messages, and then have Spark streaming enabled and running. And so what it does, it picks up these messages, it processes them, and then it generates vector embeddings from them by calling OpenAI in this particular case. I mean, you could use another LLM provider as well. and then it stores those into the database system for further processing. And it occurred to me that that would be actually a very useful use case or a very useful implementation, specifically for analysis of, say, email messages. Not necessarily transactional data, but having the LLM analyze the text, simply because many of these LLMs, they are very well designed for kind of conversational applications. We work on the three major cloud providers. Today we are using AWS. We can run on-prem as well. There's a Docker container too, but sign up for the cloud trial is the simplest and quickest way to get onboarded, and you could be up and running in a matter of minutes. So we are a multi-model database. So we do the relational naturally. That's the basis for the technology. And again, I'm almost at the point where I'm revisiting my previous content that I wrote on geospatial, time series, JSON. Haven't covered key value, but we do have at least one customer that I know of that uses SingleStore as a key value store as well, and obviously vectors. Now, the thing with vectors here is that you can find pretty much every single vendor out there that now has vector support. Naturally, I mean, it's an interesting topic and an interesting area, given the almost the exponential growth in large language models and ChatGPT and similar sort of technologies, the ability to store these representations of, say, text or videos or images or whatever in a format that a machine can understand, and then you can do useful things with. Bear in mind that SingleStore has had vector support for quite some time now, 2017, I think, going back a few years. So it was a financial customer, I believe, that originally requested it. Earlier this year, we added a dedicated vector type, as well as some cool features such as approximate nearest neighbor indexing, ANN, and we've covered those in previous webinars. Finally, just to round it off, real-time applications, dynamic experiences, dashboards, ad hoc queries, machine learning, just some of the possibilities that you could use with the SingleStore today. And then just very quickly, just to show you some of the tools and technologies that you could work very easily with SingleStore. So just last night, for example, I was reviewing some old content looking at using Spark, for example, with SingleStore. This is using alternating least squares. So this is great for recommender systems, for example. And it's a great way to take some of the strengths of a distributed processing engine such as Spark, which scales very well, scale out in memory, but then combine it with persistence in a database system. And SingleStore will happily store vectors for you and then do the in-database machine learning operations. So, that's a great combination. But you could use Python as well, which we're going to use for the demos today. Vector functions I've already mentioned, Euclidean distance, dot product. These have been there for quite some time. Excuse me. Something else that may be of interest to you is this concept of code engine using WebAssembly. So again, it's something that I was just reviewing recently, where if you have some feature or function that you would like, but the database system doesn't support it, essentially you can write that now, and you could write it in, say, C, C++, Rust or something, package that up, load that into the database system, and then the engine will treat that as a user-defined function. And that will give you the opportunity to extend the capabilities of the engine. And if you're worried, well, where does this actually run? It runs in its own space. So if there is some bug, for example, in your implementation, it's not going to bring the entire database system or the entire cluster crashing down. It's fine. I mean, it's handled in an entirely separate space. And then last but not least, I mean, there are lots of LLM providers. We do lots of sessions using OpenAI, for example, but equally there are many other open source and commercial offerings available too. So this is not an exhaustive list, okay, just some examples. And again, if you're interested in some of these integrations, let us know. We can point you to appropriate blog posts and resources. So if we look at banking then, well, generative AI, lots of potential there. 300 billion US dollars in additional value for banking and financial services. That is a huge sum of money. It is more than the gross domestic product of, I think, quite a few countries around the world. So, this is an enormous sort of potential. And some of the areas that we may see utilizing this are things like customer operations and support, marketing, software engineering, risk, and legal. And I think the chart there on the right-hand side, forgive me, the text is a little bit too small for my poor eyes to read. But this is, I think, taken from a commercial report there, just showing you some of the potential and some of the sort of industry revenue. And, it gives you an understanding and that yes, there's a need for this and great potential and possibilities to apply this to solve real problems, which I think is the important thing. At the end of the day, and I'm old enough to have seen many waves of technology sometimes come and, sometimes they've died and not got very far, or they've survived, adapted. But generative AI is one of these things that obviously we're all interested in. I mean, I use ChatGPT heavily. I'm sure many of you do as well. But seeing applications for this for real world problems, analysis of messages, for example, being able to give you greater insights into your data. These are possible through many frameworks, for example. Looking at things like LangChain, Llama Index, for example, are pretty awesome. And the ability to query in natural language as well. That's interesting too, particularly if you're not particularly skilled in SQL, for example. But there are important things to be aware of there as well. So natural language can be vague. It may not necessarily be entirely clear to a system what it is you're trying to do. I've demonstrated this actually recently. We have a video up on YouTube, just posted in the last couple of days, where I'm doing some stock analysis, for example. And I've got some questions in English that I want to ask. And it's important that I had to go through the process of writing the SQL query that would do the equivalent for me, and then asking, in English the same thing. And sometimes the answers that came back were incorrect. And I had to go through that process of refining my question in English to be more precise, more focused. And so there was no ambiguity or no vagueness about what I was trying to search for. So these things are useful, but have some issues associated with them. Okay, not everything is going to be perfect from the beginning. So if we look at financial fraud, and I apologize for this, you'll need a microscope to read this, but essentially what I tried to do here was identify some of the key things that, a dozen or so issues around comparing these various approaches. So looking at, for example, at methodology, looking at how data are handled, the detection strategy, how accurate is it, how scalable is it, is it flexible as well, the response time, and particularly for fraud detection, you want things to be fast. What is the level of expertise that you need in this, or that you can acquire or get from commercial sources? How adaptable is it? Things like false positives, that's important as well. And the implementation cost. I mean, these days, I hear figures, particularly for this generative AI, that the amount of electricity that's used for these is just going off the scale. And so this is going to be another important issue. And also, last but not least, regulatory compliance. That could be very, very relevant. And so what I did here was to compare the kind of traditional approach. And what I mean by that is human in the loop. Essentially, a person deals with the fraudulent transactions. And I used to get in the past, occasionally, when my credit card, and I've had this happen to me a couple of times, maybe someone has obtained details of a credit card that I have, they've used it. I might get a phone call from my bank. There's a real sort of person on the other end of it, ask me some questions, did I spend this amount of money here? And of course, I go through the security process as well. And then I would say, no, I did not. And then straight away, they can act upon that information, block the card, send me some paperwork to fill in saying that, I did not authorize these transactions, and then I get reimbursed for those. So that used to happen quite frequently in the past. I think it's got a lot better because of machine learning. Okay, so this is something that a lot of you can find a lot of its skill and expertise, plenty of packages, plenty of libraries, very easy to use, available in, a wide variety of languages. I mean, Python and R, obviously, but many other languages as well. And then, of course, the up and coming, if you like, the new kid on the block, the large language LLM providers. How are they able to handle this as well? Now, I won't go through all of this with you, but let me do a kind of a TLDR. Too long, didn't read. So in terms of the traditional approach, the key things that I observed is that generally it's predefined rules. Statistical analysis, manual reviews, great for known fraud patterns, but less adaptable and scalable, high false positives and slower response times, because you do need someone to actually look at that and to be able to make an assessment and a judgment. With machine learning, learn from data, detecting new and unknown fraud patterns. So it's much better. Higher accuracy, very scalable as well. You've got some great tools and technologies. I mentioned Spark a little bit earlier, for example, that, it's got MLib, which again, it's a distributed processing engine, so it can process huge quantities of data at scale and be able to, apply these machine learning techniques. Very adaptable as well with real-time responses, but you do require some data science expertise. Moderate implementation costs, I would say. I mean, the costs have come down considerably. The advent of machine learning, I mean, many of the techniques around this have been around for a very long time, but the cost of computing has gone down considerably. You can spend literally just pennies now, get yourself some online cloud resources, and you can process vast quantities of data very, very quickly. And then last but not least, in terms of LLMs, well, these generally advanced natural language processing, which I kind of talked about a few moments ago, and contextual analysis to detect fraud patterns. Highly adaptive and scalable with real-time capabilities. I think that's possible today, but does require significant expertise and high initial costs, but offers low ongoing maintenance and advanced fraud detection. Now, some of these things I've kind of taken a little bit of artistic license in the sense that I'm kind of projecting it forward a little bit. Some of those may not be possible today, in the sense that because this area is rapidly moving and it's changing very, very quickly, we are seeing lots of great innovations coming along. At the moment, though, and I'll give you my initial thoughts on this, that I think it's still largely an area that won't meet the requirements as of today. That's my take on it. I'm happy to be proved wrong, but I think going forward, given the pace of change, how much we are seeing in terms of advances in this area, I think it's not going to be very long before these capabilities will really be able to assist us for this type of sort of problem that we're looking for. All right. So let me switch now to show you what I'm going to use in terms of the demos I show you. And again, Yukti will share the GitHub repo with you, and then I'll talk about some of the resources as well. Okay, so we'll share those with you. So 3 different technologies that I looked at. So one is the kind of traditional machine learning approach, okay, using logistic regression. Why? Because it's a simple binary classification. Either something is going to be fraudulent or it's not going to be fraudulent, all right? You make a decision one way or the other. FinBERT, okay, this is based on the BERT series of models from Google, and this is specifically geared around financial, pre-trained model for financial text analysis. And then the last one is using an LLM. Okay, now it's GPT-2 for the simple reason that it's free, right? You don't need to pay anything. You don't need a key. Although I would say that the cost of using these LLMs has gone down considerably. And let me share some thoughts with you. So when I originally did something on fraud detection, I think it was around about March or April last year, I spent quite a bit of money because I was evaluating OpenAI and seeing how that compared against Apache Spark and scikit-learn for exactly this type of problem, but looking at kind of transactional data. And, I spent quite a bit of money in terms of getting anything out of it. In the end, OpenAI, the results were rather unsatisfactory. Spark and actually scikit-learn did far better. But what I've noticed is that, again, because of the new models that these LLM providers are releasing, and the charging, the billing that you're getting, it's far less today. You know, there was a figure I quoted, I think last time I did one of these webinars, which were like 10% of what it used to be. I think it's even less than that now. So literally you are paying pennies for these now, and the opportunity to really analyze large quantities of text for very small amounts. Now, let me just give you a little bit of context again. So with the original sort of credit card fraud detection that I tried out, the LLMs originally, as I mentioned, sort of March, April last year, this was the kind of data set that I used. So in a sense, I was trying to push the LLM to try and really solve a problem which I think it was not designed for. But, you know, I wanted to have a go. I mean, it's okay. If you disprove the hypothesis, that's fine. But what I was curious to see was just how well it would do for looking at this data here, which is drawn from real data. I think these are real transactions from collected, I think, in Europe somewhere. And you've got the vast majority of these are actually correct. They are not fraudulent, and you've got a tiny, tiny proportion which are fraudulent. So that's going to be a challenge even for machine learning models. You know, how well would an LLM do? And then again, because this is kind of transactional data, something that a conversational AI may not necessarily be the best solution for, how well would it do if I said to it, well, look, I am going to share some data with you, and what I want you to do is to analyze this and then build a model that will allow you to detect fraudulent transactions. Then I'm going to show you some new data which you haven't seen before, and then you tell me what you think are the fraudulent and non-fraudulent transactions. So on this score, as I said, when I evaluated this originally, the LLM didn't do particularly well, but that's okay. Like I said, I'm trying to push the technology in a direction probably for something it wasn't designed for. Today, maybe that would not be the case. So my thoughts when I wanted to kind of revisit this topic again was to say, well, okay, I picked something before that wasn't suitable for an LLM. How about if I went the other direction and looked at something in terms of textual-based data? So this is the financial statement fraud data, again, from Kaggle, from this gentleman here. Okay, so Amit. Okay, so it's his GitHub repo that I actually took some of this data from. And this is actually based on SEC filings in the United States. Okay, so it's not actually a huge quantity of data. It's only 170 rows of data, but you've got essentially two columns. One column contains the whether, you know, it's a binary. Was this a fraudulent or non-fraudulent? And then you've got a huge kind of text field, which is the actual SEC filing. And that is what's being analyzed. And again, it's kind of 50-50. Okay, so 85 of these were non-fraudulent, 85 of them were fraudulent. So this is kind of the other extreme, if you like. So rather than looking at transactional data, now we're looking at text-based data, and we're trying to evaluate that and see how well would the LLM do against this versus the traditional logistic regression, and then looking at something like FinBERT, which is specifically designed for this type of analysis as well. Would these other technologies be able to do as well as, say, a machine learning algorithm? So again, this is you know, in a sense, it's the other side of the coin. So I feel now I've done the business. Okay, I've looked at one kind of approach where it wasn't entirely suitable for an LLM. Now I'm looking at the other approach where it's much better attuned to perhaps a conversational AI type of scenario. And keep in mind that many of these LLM providers are now coming up with specific models that are much more geared towards heavy kind of lifting, if you like, in terms of processing, and then giving you much more detailed reasoning into how they arrived at certain decisions. Again, great, you know, place to be right now. And this is just going to get better and better. So more about this in due course. So Yukti, hopefully will have shared the GitHub repo, which is where you will find my notebooks, okay, which I'm going to use today. And I'll show you the evaluation of that. And let's just go back here. Okay, to this. And let me just show you this. Okay, so let's just switch to the demos, okay? So what I've done is I've signed up, and this is an account. So yes, I have some corporate accounts here as well, but I was curious to go through that process of just signing up from an account as though it didn't work for SingleStore. And like I said, it's a breeze. I mean, it's a couple of minutes of your time. Immediately you log in, you are given some compute resources. Okay, so here you can see I've provisioned something specifically, but if I switch, there's a whole bunch of things, this environment that I'm sharing with other colleagues. But with a new account, what you will see is that as you log in and look in under deployments, you will see that you've got this kind of workspace that's provisioned for you. And on the right-hand side will be a database already. So you have nothing to do there. Straight away, you can hit the ground running and you can start to be productive. So I've actually provisioned these resources myself because I need a little bit of extra processing power and some additional memory and capability. So the free tier will give you a certain level of compute and database resources, and the trial website, I think it's mentioned on there, you get sort of a set of credits as well. So if you find that the free tier is insufficient, you can just provision these additional resources yourself as well. Okay, so that's fine. So this is Data Studio. Now, in case you're wondering, well, how do I load in the notebooks? Well, just go here. Okay, go to Data Studio here on the left nav. Okay, so this is using the new UI. And then if you click on this here, okay, you can see, oops, sorry about that. It's been sitting idle for some time. I'll just leave that. There we go. Okay, and so let me just click on this. And then here you can see this big purple box. And if you click on this, you get two options. You'll see two options. I've got three, again, because this is a slightly different account. And so you see that you've got the option to create a new notebook or import one from file, okay? So if you select the import from file, basically you just drag the IPython notebook here and away you go, okay? You can just choose whether you want it personal or shared. Just keep it on personal. And then this box here will activate, okay? And then we'll just import that for you. It's as simple as that. So straight away, okay? So there's 4 notebooks. So sorry about this, I'm not sure. Let me just try and refresh this. Fortunately, I ran this a little bit earlier. So all of this should be working okay. There we are. That's it. Okay. So let me show you the steps that I've taken. Okay. And then again, keep an eye on the time because we want to leave time for questions as well. So this first notebook essentially takes that data set from the Kaggle, okay, the financial fraud data, the textual SEC filings, okay, the 85 that are fraudulent and 85 that are okay. And what I've simply done is I've used Stage to read that in. And it's a CSV file, and then I've just shown the couple of rows here, so you can see the 2 columns here. Okay, so I've got the one here, which is the notice it says Filings. Okay, so I change that in a moment, and whether it's fraudulent or not. So the text column here is actually quite large. Okay, we're only seeing a part of it, and so one of the first things I do is actually I'm not sure why Amit called it Filings, but I changed Filings to Filings, which I think is the correct use there of the word. Create the database here, and this is done using the standard tier. Okay, to bear that in mind. So, like I said, I need a little bit more processing power, and you'll understand why in just a moment. And then essentially, we just store that in a database. Okay. And that's all this does. And then just a sanity check here, just to retrieve that data back, just to take a look that it's actually gone in correctly. And it has. Okay, so this is just a pandas data frame, just reading that back into this space here. So we've got the data stored in a database system. And then we've got 3 notebooks that cover each of those specific technologies. So the first one here is logistic regression, okay? So at the beginning of each notebook, just a little bit of a TLDR and a summary then just to say what we are doing and why we are doing this, and then just to walk through the process. Now, with this, what I've simply done is taken the code. I was going to write this myself, and then I came across this work by Amit. Let me show you his GitHub repo here. Okay, so this is mentioned in my acknowledgement at the bottom of each notebook. Okay, the link to the because it's an MIT license, and there's a hyperlink to his repo. Okay, so basically we just do the libraries here, connect to the database system here. We read that data back in to the notebook here, and then we just do the train test split. We use this TF IDF, okay, to pre-process the text because it's textual data. Okay, that's what we need to work with, and then we create this logistic regression model, and it runs very, very quickly. So if you take a look at the numbers here, again, if you're sharp-eyed, let me blow that up for you. That took just a tad under 16 seconds for it to do all of this, okay? So all of this process here, pre-process the textual data, train the logistic regression model, evaluate the model on the validation set, and evaluate the model on the test set, all done in under 16 seconds. Very fast. And then what's the level of accuracy did we achieve? Well, that's not bad. We get very high levels of accuracy. Sorry, I think my magnifier is not going to show this correctly, but let me just show you and read off the numbers. So it's 94% validation accuracy, precision is 95%, recall 95%. And if you're familiar with data science, I mean, you will know that these numbers are pretty good. And then we just do a plot here in terms of looking at the overall numbers, and we actually do very well. So the model itself, and we are interested in this and this. Okay, so you can see that most of the numbers lie there. The misclassifications are tiny, just one here and one here. So overall, the cost in terms of resources here was very low. It's very, very fast. It's very economical. And then certainly if you're building real-time AI, I think something like this, build your model, apply it to the stream of data that's coming in, and you'll get very high levels of accuracy. And of course, you can still have the human in the loop, if you like. Someone can still, anything that kind of looks suspicious, but the system hasn't quite got it right, maybe, set that aside, get someone to actually look at that and verify that, yes, this is fraudulent or non-fraudulent. But overall, the results there are very impressive, in my humble opinion. So if we take a look at this, which is a great indication. So this line here is the kind of the 50% line. It's a bit like tossing a coin, in what you want is this curve here to be moving in this direction. So you can see that we've got pretty awesome results there, 96% in terms of this ROC curve. And then again, this one is the precision recall, and that's at 0.97. Again, we want this one to be moving in this direction, and you can see that it's almost hugging the border there on the right-hand side, along the top, and on the right-hand side there. So very impressive results, very fast, very economical. This is giving us very good results for very little spend. Very happy with that. And then here, as I said before, is the MIT license, and there's the link to Amit's GitHub repo if you want further details. Okay, so take it a step further then. Suppose we want to try and evaluate something like FinBERT here, which is specifically designed to process this, let's have a look, pre-trained BERT model for sequence classification, pardon me. And the model is trained using a training loop over several epochs, okay? So in this particular case, we actually have to do a little bit of heavy lifting. It needs more time and effort in terms of taking this, despite the fact that this is actually specifically designed for financial data. So here, again, going through the process, similar sort of setup, import the libraries, okay, bring our data in. Actually, I could just make this a bit bigger. Let's just zoom in a bit, make that larger for you. Although if you're going to download the notebooks, you'll be able to see it yourself, okay? So there we go. So we go through this process again, and this is built by Yi Yang at the Hong Kong University of Science and Technology. Okay, so this is where this FinBERT comes from. So we load this in, we do the train test split. Okay, so that's pretty fast. And then it takes very short amount of time to actually just get this running. But the training loop here in terms of applying it is very costly. If we go down here and take a look, so it's a fair chunk of code there. So this took in excess of about 10 minutes there. Sometimes this can go up to 18 to 20 minutes, I've noticed. So it's kind of variable. And again, it goes through these kind of epochs in terms of training loss, which gets less and less. Okay, so the accuracy improves over time and then gets quite high towards the end there. And then overall, how did we do in terms of results? Well, not bad, but not as good as the previous one. So you can see here that we've got where the true label was fraud, it's actually been identified as non-fraudulent here. Okay, so this is rather serious type 2 error, I believe. So 9 of those, so quite a few misclassifications there. On the other part of it, where we've got the non-fraudulent, it's done a lot better, only 2 misclassifications. So we're probably going to annoy some customers there, but that's okay, right? It's less serious than that one. So overall with this one, sort of mediocre, all right? I would say it's, given the fact that it's specifically focused on financial, less impressive results than the logistic regression, much more time consuming in terms of resource, and actually variable in terms of how much time it takes to run and to actually get some meaningful data out of this. And again, if we take a look at the curves, we see that the results are not quite as good as we saw with the last one. So that is a little bit better. What's that? 0.68. Okay, a little bit better than flipping a coin. So, and then here, well, that's not too bad. But still not quite as good as the previous one. Okay, so again, I mean, if you're going to build real-time analysis, this one with its current results is something that I probably wouldn't use. Would I consider using it? Possibly. I think this environment to run these at scale needs much more resources than I currently have within this where I'm running it. So I did have to make some sacrifices in terms of batch sizes and things, which I think may have affected the results. I'm not sure. It's something that I can't test at the moment. But again, if you have the means and the resources to do this locally, and you've got something with much more power and much more memory, then you can try and tweak those settings, test it out, and see how the results, what sort of results you get back. Okay, and then in the last case, then we look at the GPT-2. Okay, so this is free. That was the reason for using it, so no cost at all. And I know it can be a little bit cumbersome. You know, sometimes we want to use these LLMs. Yes, they are very cheap to use now. The cost is very small, but still you have to register a credit card and you have to go through that process of validation and so on. And not everybody can do that. I appreciate that. You know, it depends where you are in the world. So again, similar sort of setup. We import the libraries. We get the data in from the database system, and then we go through that process of, and again, apologies for this. I think this is because of the error that you saw a little bit earlier when I was just switching to this environment. But again, going through that process of splitting the training, validation, test sets, and so on, that's pretty fast. And again, I had to make a few sacrifices here as well in terms of the batch sizes, simply because I've only got 14 gigabytes of memory within this environment. And then similar sort of setup to the FinBERT, processing this. And this took a whopping 26 minutes to evaluate. So even more time consuming than that. So again, training accuracy, yes, does get better over time. And if we evaluate this, overall, these numbers look somewhat less impressive. And the best way to see it is a visualization. Just see the plot here. So again, actually slightly worse than FinBERT. We are still getting some misclassifications here, as you can see. That's a bit serious. The numbers are very similar to the previous case. And then here you can see very similar to the previous curve. So how are we doing? 0.66. Okay, so a little bit better than flipping a coin. And then this is very unusual. I don't think I've ever seen anything like this. I'm at a little bit of a loss to explain how this has come about. It's a very strange curve. So, but overall assessment there is right. Granted that this is a little bit old, we could probably do better with modern LLMs, and let me set that as a challenge for you, but perhaps for myself as well, to try it out with something a bit modern, up to date, something a bit more focused. As I mentioned a little bit earlier, some of these LLM providers are coming up now with specific models designed for this kind of problem, I think. So we could do a lot better. But currently, the state of the art, as far as this is concerned, okay, we are using technology a little bit older than we might think, and perhaps we would get better results today. I'm still a little bit of the mind that what I see is that conversational AI is awesome for some problems. I use ChatGPT quite heavily these days. Sometimes there's a coding issue. For example, just yesterday, I was very interested to understand alternating least squares and Spark's implementation. I haven't got time to go away and dig around and spend a day or two just finding the technical details in the implementation. So I was curious to see how does it retain this kind of internal mechanism, this numbers, if you like, this mapping back to the original data. How could I achieve that? Because one of the things that Spark does is that it generates its own kind of identifiers, and therefore it's not something directly accessible when it's produced its results. But I asked ChatGPT a detailed question about it, and it actually came back and gave me a very reasonable answer and showed me an example of how it actually works. And that was very, very helpful. So from that perspective, I think the technology is great. Could it be applied to this? I think certainly for the Spark streaming example that I shared with you a little bit earlier on, that I mentioned, that analysis of text, email, messages, documents, that could be very useful, identifying and looking for fraudulent patterns, but you'd need to train it and teach it. Simply giving it this text and then just asking it, what do you think? I think that's not going to work well. It needs some context. It needs to see some examples to be able to comprehend what it is that's meaningful to you that you are asking it this question. So you've got to be able to teach it and give it enough examples to work from. And I think the challenge there is that finding, again, the compute resources to do that. Certainly for this particular example, you saw that it took nearly half an hour to work through and actually get something back before it's able to produce some results at the end there. Okay, so again, just a quick mention there. So this was the original data set that I looked at, and I will revisit this and possibly write this up as a blog post, actually, I think, rather than do another webinar. Although if Yuxi is interested, maybe we'll do that. Or if you are interested, let her know, and then we can try that. So this is the one we currently looked at. So the two kind of extremes, if you like, transactional data and then textual-based data. In neither of those, currently am I overly impressed, okay? Not impressed. As, was it Shania Twain? I think that don't impress me much. So I think there's a song. Here you can get the notebooks, okay, from the repo. Please sign up for the account to try these out for yourselves. And so let's just summarize then. So model complexity. Well, FinBERT, GPT-2 offer higher performance in text classification than Logistic regression, okay, but need more computational resources. And then that's the key thing, that you can, I think, with appropriate tuning, maybe you could get good results out of that. I'm a little bit limited in this environment. Evaluation metrics, well, there's a whole bunch of things. Don't just look for accuracy, okay? There's a whole range of things that you should look at: precision, recall, F1 score, and so on, right? You evaluate the umbrella of numbers that you get back to give you the big picture. And that offers deeper insights than accuracy alone. Okay, so look at those in detail. The data preprocessing, effective tokenization and handling padding are crucial for transformer models, okay, which is what we were using later. And then visualization, that confusion matrices and RSE curves help interpret model performance. A picture is worth 1,000 words. So rather than trying to, look at the detailed results, just seeing the analysis in a visual way immediately shows you what's happening and gives you a much kind of greater insight into the data. So currently, I think my preference is that, and my kind of assessment on this is that I think certainly the existing machine learning techniques work really well today. You can easily apply them to real-time data. I think lots of banks, financial institutions do that anyway. As far as some of these other models are concerned, watch this space, I think. Okay, be patient, wait. By all means, experiment, try them out, test them out, evaluate them. There are great tools coming in the pipeline, I feel, and I think there will come a point in time where the technology will be general purpose enough and good enough to use for a wide range of problems, on the one hand, as well as very specific vertical and industry specific models as well that will, hopefully focus on this particular domain as well. And as far as the analysis in real time is concerned, very easy to do. As I mentioned, certainly if you're using SingleStore, something like pipelines will be awesome. You can ingest the data at scale, process that data as it's arriving. And so getting these real-time insights, once you've built your model, just simply apply it to the data as it's arriving and then be able to make a decision very quickly. And in that context, if you're interested and have some thoughts, or maybe, you've got a project in mind, well, my colleagues within the professional services team can help you assess, design and plan, migrate and validate, post-migration support, cutover support, and hold you through that process. And we can go through that with you. If there is some problem that you are currently looking at or some technology that you're evaluating, and maybe SingleStore is a good solution to that, plus some machine learning capabilities as well, we'll be very happy to discuss that with you. The customer, we are hiring. So SingleStore has a careers page. Okay, singlestore.com/careers. Please check that out. And quote from one of my favorite authors, Arthur C. Clarke. So any sufficiently advanced technology is indistinguishable from magic. And so a lot of these LLMs behave like magic. It's almost like you're talking to a real human being. And then in terms of the responses that you get back, even within this sort of year and a half or so that I've been using ChatGPT, I've noticed that the quality of its responses has improved. It's much faster, and its accuracy and the focus in terms of the results that it brings has got better and better. The hallucinations seem to be far less today than they were. And that, again, if you're going to use it for a specific problem, you have greater control over these as well, the temperature settings, for example. Okay, so with that, Yukti, I finished early today, so I think that's a good thing. Normally we run over and have no time for any questions. So I'll leave it to you to pick a couple that we can help answer. And that should bring us to the top of the hour.
All right. So thanks everyone for joining. We really appreciate you all to when that you joined this session. So just a reminder that we are officially starting the Q&A session. So feel free to add in any questions that you have about the session or anything else regarding SingleStore in the chat. You can use the Zoom Q&A button, which is present at the bottom of your console. So we have one question about the recording. Yes, the recording will be available. You can see it on our website after 24 hours. So, we have a comment that the link to your notebook is incomplete. There might be an issue from.
Which one was that, Yukti? Was it the GitHub repo?
Right. Yeah, I think so. Just give me a second. I'll
Actually,
repost that.
it's
That's
really
a bit
easy.
strange. Yeah,
It's very easy.
it's
Just
all
go to
right.
github.com very fat boy, okay? And in case you're wondering why,
What were you
that was a joke
thinking?
between me and my wife. So, and then I got upset and I said, I'm going to call myself that now. So,
All
so
right.
/ fraud hyphen detection, okay?
Hey.
And in case you're interested, the older work that I did, the initial work using Spark, Scikit-learn, and OpenAI, that repo is there as well. It's under something called GPT-workshop. And I am in the process of reviewing this older content. I'm going through it gradually and just updating it as well. So I plan to update that work too in the very near future, as soon as I've got time. Currently, I'm just reviewing lots of old blog posts and again, checking the code. So it's a lengthy process, as you know, especially if you've got lots of stuff to get through. But hopefully, we'll get that done as well. So that'd be if you want to try that as well, that would be a great way to see the other approach, if you like. So here we are analyzing text, trying to look for patterns. There, it's kind of transactional data, numbers that we are trying to deal with. And, that problem is less suited, I would say, to an LLM than this one, where I think it's much closer to the kind of thing that it would be better at.
Okay, so we have one question from Craig. They say
Yeah.
that, hi, Akmal, do you have any experience with using CADE for fraud detection? CADE.
CAD? No, I don't. That's maybe it's something I should go away and look into. Thank you very much for that. So I'll evaluate that and do a bit of research on that.
All
Maybe it's a
right.
topic we can cover for the future.
Exactly. If this is something that is like,
Yeah.
of relevance, we can actually make
Yeah.
this another webinar, right? That would
Yeah.
actually be fun if like SingleStore is able to handle that. So, all
Yeah.
right. So we have one question from Shaji. They say that, can you elaborate on the pipeline concept with an example or point to a link? Uh, and they're also
Yes.
asking for your slides. It will be included in the recording. Okay, so there you
Yes,
go.
that's right. Okay, so for the pipeline, let me see if I've got something here. I've been working on some things. Let me just have a look if I've got something. Fintech chatbot. Let me just show you this. I'll load it up for you, okay? And by the way, I'll show you the GitHub repo for this as well. So this was something I presented at Big Data London, harnessing LLMs and speech recognition for personalized recommendation engines. So we're taking a stock ticker. This is a Kafka feed, okay? So here is the pipeline that we've got. And now in this particular case, the pipeline does not require any credentials, username and password to the actual Kafka broker. It's open, publicly open, okay? So I simply use the keyword to create the pipeline. I tell it where to get the data. It's a Kafka broker, and here's the tick data coming in, okay? Which table this is going into. I just provide some information, what the field separator is here, for example, and then the names of the individual columns here. Okay, so you can see very simple and straightforward. Now, if you've got, say, a broker that requires you to put your username and password in to access the data, you can do that as well. This is a super simple version, just without the need, so anyone can actually use this. And then what this will do is it will create it, but then we just start the pipeline further down. So here we test it and get a symbol, which I'm just limiting it to 1. So it just returns me 1, which is fine. And then we just say start pipeline. Okay. And if you're going to use this, please don't forget to stop the pipeline. Otherwise, at some point in time, your database will blow up. Okay. Because you're going to feed in too much data. You need to set some conditions, either process that and discard the data or store it, or having a sufficient storage to be able to do with that. In the free tier, you probably run out of space long before that, okay? But that's essentially how you do it, okay? Very simple way to do it. And if you want this, it's on the, GitHub as well, okay? So if you just go to the GitHub and then just search for, let me see. Speech. Okay. Now I've even forgotten the name of the. We'll send the link out. I think it's easier. My brain's not working at this time. It's nearly 7 in the evening. my time. My apologies. But yeah, we can send that out to you. So that's essentially how you do it, okay? And remember, this is done in parallel. So the way that the pipeline works is that if you've got a source, and remember, SingleStore is a scale out, shared nothing database system. So you've got multiple nodes, and the pipeline will read the data in parallel at scale. So it's not, you don't just reading it at one sort of point and then it's sending the data out, but you can do that in parallel at scale. Okay, so you can ingest vast quantities of data very, very quickly.
All right. So it's like we're almost, I mean, we're done with the time. So thanks everyone for joining. And unfortunately, we can't take in more questions. I actually have another meeting to join. So uh, we have amazing webinars that are happening. So tomorrow, our CMO, Mr. Madhukar, they are going to do a very interesting webinar. It's called FreeDB Faceoff, where he will be comparing different databases and how they handle like huge chunks of data and what's the response time. So it will be a hands-on session. So we'll also have Akmal joining in for the Q&A. So if you want to ask him anything during that session, feel free to tune in. So um, on October 15th, that's I think that's a Monday. We are presenting how to build an LLM powered chatbot powered by agents. So that will be conducted by Vinija, who is an AI leader at Amazon. So stay tuned for that, and I hope to see you all there. That was such a great session, Akmal. Thanks so much for joining, and thanks to our audience as well. So just another announcement as we close today. We will be announcing the winner for today's raffle by the end of the day for anyone that has tried out SingleStore today. So anyone that has tried and loaded data will be eligible and be entered to win. If for anyone that joined late and is not aware of this, you can still try out SingleStore, and you also have the code. I will be sending out a follow-up email as well. So you can use that as an inspiration, or maybe you can load in your own data. So yeah, feel free to try and stay tuned. If you will be the winner, you will be alerted via email. So keep an eye out. And thanks everyone for joining. Have a great rest of the day. And I hope to see you all in the future sessions. Take care, Akmal. Take care, everyone. Bye bye.
Bye-bye.